Okay, velocity is rate of change of position with respect to clock time. Acceleration is rate of change of velocity with respect to clock time. So, if we have position function, as we do in the problem, s of t equals 2t squared minus 4t plus 3, then to find the velocity function, we take the derivative of the position function. Now I'll use the ds dt notation. And the derivative is very easy to calculate, very straightforward. Looks like something brushed across this board when I was moving it. Okay, 2t squared, derivative is 4t, negative 4t, derivative is just negative 4. And then the acceleration is the derivative with respect to clock time of the velocity function, and that is the second derivative of the position function with respect to clock time. We just take a derivative of the velocity function, we get 4. That's our acceleration function. So we have our position function. The first derivative is the velocity function. The derivative of that is the acceleration function. And it's the derivative. Why is it the derivative? Because it's the rate of change. The rate of change of a function with respect to its variable is the derivative with respect to that variable. So the function that gives you the rate of change for the s of t function is the ds dt function, derivative of s with respect to t. And we know that a rate of change is a change in one thing divided by a change in another. This is much like a delta s over a delta t, but as you know, when we do the derivative, we do a limiting process on a delta s over delta t expression, taking the limit as the delta t goes to 0, we get what we call then the ds over dt function, the derivative function. So, the acceleration being the rate of change of position with respect to clock time, we can say that acceleration is the second derivative of the position function. Now that's with respect to clock time, but just a note here, second derivative of position. And this is, it's s double prime of t, and we can also write that as second derivative of s with respect to t. Putting a 2 on the d here in the numerator and a 2 on the t in the denominator tells us that we're doing the second derivative. The next question, we have the position function s of t equals 3t over 2 minus t, and what we want to find is the rate of change of the velocity. Now how are we going to do that? Well, you know, when we did this in class, people just started plugging in numbers into the s of t function. And that's not going to give you anything related to anything but the s of t function. It's not going to give you a velocity. It's not going to give you a rate of change of velocity. So we have to be careful to identify what it is that we're trying to find. We're trying to find the rate of change of the velocity. We're not given the velocity. So before we can find the rate of change of the velocity, we better find the velocity function. Then find the rate of change of the velocity function. So to find the velocity function, we take the derivative of our position function. So first we find our velocity function. Velocity function is the derivative of our position function, and we do that using the quotient rule. Okay, derivative of the numerator times the denominator, here. The numerator times the derivative of the denominator, but subtracted, divided by the square of the denominator. And it's very straightforward. The derivative of 3t is just 3. The derivative of 2 minus t is just negative 1. And we end up with negative 3t here and a positive 3t here. So the 3t goes away. We're just left with the, I said 3 in the numerator, and it should be 6. 3 times 2 being, 3 times 2 being 6. It looks like I subtracted a 3 because I wasn't being careful. So let me correct that. So our derivative of our position function is this, and that is our velocity function. And again, we got some letters here that somehow got smudged out. That's not unusual on the edges of the board, but in the middle, I don't know how that happened. Okay, made the correction. We have 6 over 2 minus t quantity squared, 3 minus 2 being 6. So we have found our v of t function, but we're trying to find the rate of change of the velocity function. We have now the velocity function. How do we get its rate of change? Well, we take the derivative of the velocity function. Now this function is a composite. F of u equals 3 over u squared, g of t equals 2 minus t. We have a 3 over squares, that's our 3 over u squared, etc. Okay, so we do that, and we take our derivative of the g of t function, which is -1, and then our derivative of 3 over u squared is -6 over u cubed. And so we get, okay, the f of u function isn't written right there. Okay, the f of u function is 6 over u squared, clearly, because we have 6 over the denominator squared. So when we take the derivative of the f of u function, we get -12 over u cubed. That's very straightforward. And then plugging in the g of t function for u, we get -12 over the quantity 2 minus t cubed, giving us dv dt equals 12 over quantity 2 minus t cubed. So that's the rate of change of our velocity function. Okay, this is rate of change of velocity. So again, starting with our position function, to get the rate of change of velocity, first we had to find the velocity function, taking the derivative of the position function. And then we had to find the rate of change of the velocity function, which is the derivative of the velocity function. So now we're asked to calculate the velocity function, or the rate of change of the velocity function for t equals 2, 4, 6, and 8, and see if we can see a trend. So the rate of change at 2 is undefined because, of course, we put 2 in for t, our denominator is 0. The rate of change here at 4, well, we just plug 4 in, and we do the arithmetic. We get -3/2. Then we proceed to plug in 6 and 8, and the plug-in is very straightforward. We get -3 over 16, -1 over 18. So we find what? The rate of the velocity change. In the first place, we might note that it's always negative. The velocity is decreasing, okay? Getting slower and slower. Also, the rate is approaching 0. So the rate of velocity change is slowing. Doesn't mean the velocity is necessarily approaching 0, but the rate at which it's changing is approaching 0. So velocity is decreasing, but decreasing more and more slowly.